Here it goes. The meeting is now being recorded. How exciting.
Why is it being recorded again?
Say that again, bud.
Why is it being recorded?
Because so you have the information from the lecture in case people have poor bandwidth or they can't see it really well. They'll get to at least see it well the second time or watching it on YouTube.
Oh, yeah, that's a good idea. Speaking of YouTube, you should like and subscribe to Dan Brody.
He shoots and scores. Way to go, Nelson. And when you're watching those YouTube
We have to
videos,
get 1 million milestone.
they send me something, right?
Get Brody a plaque. Yeah, get Brody a plaque.
You'll have it on your wall in the background.
I absolutely love it. Today we are going to talk about Traversal. And the app that you're going to explore with Traversal, with code.org, is called the Mile Tracker app. And the best thing we can do is just first play with the Mile Tracker app before I talk about how it works and explain how it works. I would like you all to just go to this app and try it. So please boot up your computers, get everything fired up. I am going to force open a tab. That force open tab is going to be the Traversal Investigates Lab with the Mile Tracker application. And you can find it on code.org, or it may have just been forced open for you. One of the two happened. And I'll put it in there too. So hopefully between one of them, you're getting to the Traversal Mile Tracker app. And the way the Mile Tracker app works, I'll paste it into. I'll do a little demo of that. The way the app works is when you hit run, you're going to enter in a time, and I'll enter in a 5, and then it's going to use that 5 to say that at mile 1, imagine you're running a race, and each mile you put in your time. So at mile 1, my fastest time is 5, my slowest time is 5, and I've run 1 mile. Then I run a mile. It takes me 6 minutes to run the next mile. By the way, a 5-minute mile, I think that's like a miracle time, isn't it? The 6-minute mile is kind of what I'm used to hearing. Anyway, so now the average is 5.5. The fastest time is 5, and the slowest time is 6. And I've run a total of 2 miles. Then I start to slow down at mile 3. And you can see how my average decreases. My fastest time is still 5. My slowest time is now 8. And again, the total miles is 3. And then finally, that last mile takes me 24 minutes to complete. My average is now 10 point something. My fastest time is 5. My slowest time is 24. And somehow I've made it through 4 miles. So just play with that Mile Tracker app if you're willing for just a few seconds. I'll stop presenting so that you can have your bandwidth back. And just play with that Mile Trackers app for just a few seconds. If you're brave, feel free to look at that code, because we're going to talk about how that app works in just a few seconds. So please play with that app, and I'm going to submit attendance.
Mr. Rody, I didn't get it when we tried to force open it.
I did. Should I try forcing it again? Who didn't get it?
Link, and I can copy the link to it.
It's also lesson 10 at code.org, activity 2, Mile Tracker investigation. And if you give me a specific name, I can get you to it.
I got it.
Okay. Anyone see Kenny? Kenny, you are there. Sorry, Kenny. You're there. You're there. Sorry. You're right in there. My apologies. Just had to scroll and you were there. Few more seconds to finish up that app, or just exploring the app, because then I want to talk about the algorithms that make those traversals work. Okay, if I could beg everyone to give me their attention for just a second. Abby, I did check your attendance and it is marked present, so I'm sorry about that. I don't know why it's showing that. I did get your email, but it is showing you here, so I don't know. Strange times. I'll hit save again. Maybe that will help. All right, Brave Crew. Imagine that every time you entered a, imagine if every time you went through an array, you added another item to the times array when you added another time. So the first time you entered, let's say you entered a 14. That would be added to the times array with some kind of command like append list, append item, and then you'd add a new item. And then you entered a 10, and then your program would append item to times at the variable you, or the number you entered, which would be 10. And then imagine you carried that through so that you now have 5 miles placed into your array, starting at index 0, going through index 4, where you have times in your array of 14, 10, 8, 13, and 9. So imagine you entered those numbers, and I know you added different numbers, but it did the same thing with those numbers. So this is how that algorithm works. If you want to find the largest number in that set of data, in this set of data, I want to find the largest number. Oops, I did these different, didn't I? Let me fix that. Just so they match. I changed the data from this set to that set. Oops. All right, let's put in these times. 9, 10, 8, 13, and 7. Okay, let's put in those times. When I put in those times, what I do is I set 2 variables. I set a largest variable and a temp variable. And what I'm going to do is I'm going to store in the temp variable the current largest or biggest number. And then in a for loop, I'm going to go through the times array and each time look at the number and ask, is it the biggest number? Right now, I'm going to go to the element 0. So I go to element 0 and I visit element 0. And that value is 9. So I look at that value and I say if times at I, and times at I is 9, is bigger than the temp, which is currently 0, is that condition true? Well, yes. 9 is greater than 0. So then temp is replaced with I times at I, which is 9. So now stored in the temp is our new biggest number, which is 9. 9 is now the champion as the biggest number. Then I loop back through the for loop because that was only time 0. Now I go through the loop time 1. And I ask the same question. Is times at I, which is 10, greater than temp, which is 9? It is. So then I run this line of code and I replace temp with the current value of times I, which is 10. Oops. Then I go through the loop again. And the second time, on time with index 2, what is the current value of times at index 2? Well, that's 8. Is 8 greater than 10? And no, it is not. So I don't run this code. I skip this code and I go to the next line. I'm now on index 3. Is times at I, which is 13, greater than temp, which is 10? Why, yes, it is. So then I replace temp with times of I, which is 13. And then the last time through the loop, phew, I'm finally done. Times of I, which is 7, is it greater than temp, which is 13? No. So then at the end, I'm going to, I exit the loop because I've gone through it, the number of times once for each element in the array, and I replace the largest value, which is 13, temp, or largest gets the temp value, which is 13. So that's the way that algorithm worked. So that's the code that was in that app. And this is it written in a block format. You can see that it goes through the elements, or it traverses the array one element at a time. And it asks, are you the biggest number? If you are, you're my new winner. Are you my biggest number? If you're not, I leave my biggest number in place. And you go through the loop, through the loop, through the loop, until you've gone through all the elements. Then you are able to return the biggest element. So that's the way that loop, or that's the way that algorithm works. You can traverse an array to find the largest value. By the way, you can reverse the process to find the smallest value. And I'm not going to torture you by taking you through the whole algorithm, but I do want you to notice a key difference. Notice to find the smallest element, we have to start our temporary value at a super big number. We started with the smallest number, we started it with temp of 0. With this, we started at a really big number, assuming your time will never be 9,999,999. That's a really ridiculously big number. So that the first time through the loop, the number is replaced with the 9 being the smallest. And then 10 would be too big, it wouldn't replace it. 8 would be smaller, so it would replace it. 13 would not be smaller, so it wouldn't replace it. And then finally 7 would be the smallest, so it would replace it and return that as the result. The smallest number would be 7. Again, going through each item and saying, are you the smallest? Are you the smallest? Are you the smallest? Are you the smallest? By the way, I have a nickname for these algorithms. I call them the are you my mama algorithm. If you were a little kid, you probably read a book about this farmyard animal, and I forget the details of it, but I remember enough of it. It's something about like a llama trying to figure out who their mama is. And the llama like goes through the farm and asks a duck and says, hey, are you my mama? And the duck says, no, I'm not your mama. And then the llama goes to the next animal and the next animal until it finally reaches the llama who says, yes, I'm your mama. So that's kind of what these algorithms are like. You go through each element in the list, or in your array, sorry, and you ask it, are you the lowest? Are you the smallest? And if you ask every element within the array, you will be able to find the one that is the biggest or the one that is the smallest. Kind of cool, hey? Another algorithm that you can run is called finding the average. So you can traverse an array to find the average. Another really interesting process. What you do in this case, though, is instead of going through the array and just checking the value, you don't even have an if statement in this one. You start at 0. Then you go through a for loop that is the size of the name of the array's length, which means it will tell you how many elements are in the array. And then you go through each item, starting at the 0th item, and you develop a new total. So for this first item, your total would be 9. And then you go through that array, and the next item, you would take 9 plus 10, and you would get a new total, which is 19. Then you'd go through the array again, and you'd add the 19 to the 8, and you'd get 27. Then you'd go through it again, and you'd take the 27, and you'd add the 13, and you'd get 40. And then for this last one, you'd take the 40, you'd add another 7, and you'd get 47. So now when you exit this loop, you have a total. Then to calculate the average, what you do is you take your total and you divide it by the length of the array, which is 5, and 47 divided by 5 would be 9 point something small, because 45 would be 9 times 5, 9 times 6 would be 54, so somewhere in there. So that's how this algorithm, the average algorithm, would work transversing an array. Isn't that a really cool process? Another really cool algorithm that not only are you going to use this year, not only are you going to use next year, you can use it for the rest of your amazing coding career. Pretty cool. Here is that algorithm written out in block-based code in JavaScript. So this is that same algorithm that I just went over kind of in just kind of a demo way. And you can see how that works. The last one. I promise I'm almost done torturing you with lecture. The next one is called a filtered list. This is also cool. What you do with a filtered list is you have an array. In this case, I have an array of names. And here are my names. I got Mary, Jose, Nick, and Bella. Then I also have their grades. Mary's grade is 97. See how this is a parallel array? At index 0, I have a score of 87 for grades. And at index 0, I have a name, Mary. And these are parallel arrays where the data is matched up by index. So Jose has a 98. And Nick has a 67. And Bella has a 91. So now I can filter these lists, which is just absolutely amazing, by creating a new array. My new array is cleverly named filtered list. Let's give me one for originality, right? Okay, so we have a filtered list. Right now, nothing is in that list. It's empty. But I can go through that list and I can ask the following question to find out which students have a score of 90% or better, greater than or equal to 90. And then I can make a filtered list of the names of those students. Watch how this works. I start my for loop at element 0. I ask, is grades at I, which is 87, greater than or equal to 90? No. Since it's not, this code will not run. I go to the next iteration of the loop. I go to the bottom of the loop, travel back up to the top of the loop, and I ask for item 1. Item 1 item at index 1. 98. Is 98 greater than or equal to 90? Why, yes, it is. Because it is, I now have to run this line of code, which appends an item to the filtered list, which is the name of the person at the same index. I'm at index 1, index 0, index 1. I now add that name to my list. I have started my filtered list and filling in my filtered list. Then I go to the next score. Sorry, Nick. Let's look at Nick's score at index 2 is 67. Is 67 greater than or equal to 90? No, sorry, Nick. I cannot append your name to my list of students with a score of 90 or better. Let's go to Bella. So I go to score number 3 and I say, hey, is Bella's score of 91 greater than or equal to 90? Why, yes, it is. Because it is, I get to append an item to the filtered list. The item I'm going to add is the name at index 3. The name at index 3 is Bella. At the end of that, I could then console.log out the filtered list, which means in that little console box on the bottom of your screen, up would pop Jose and Bella. Those would be the 2 names in the list that met the criteria. Talk about awesome. Isn't that just amazing stuff? Now, what you're going to get to do today is you're going to get to see in the rest of lesson 10 some pretty cool activities. This random dog picker is really cool. And I encourage you not only to look at the random dog picker, it's not asking you to write any code in this activity. You're just kind of looking at it and checking out the way it uses this filtered list. This list that's filtering dog height and size and just making and adding pictures. It's just really, really, really cool. There also is going to be some activities that just are these code snippets, these reference guides. I remember some people in class last week saying, wouldn't it be cool, or it would have been helpful, Mr. Rohde, if there was some kind of reference guide to just remind us of what the code looks like. Well, code.org has gotten smarter, and they've now made some for you. So when you get to that reference guide, feel free to bookmark it. They have a reference guide for filtering. They have a reference guide for the average. They have a reference guide for a couple of things. I wasn't able to get them all on the screen here, but bookmark those things. You might want to use them. Then there's some transversal practice in lesson 11. There are 5 activities I'm begging you to get done today, in addition to finishing up anything you didn't get done from yesterday. So feel free to start by finishing what you didn't get done yesterday. But after you finish up what you didn't get done yesterday, feel free to then go to lesson 11 and do those lesson 11 activities, 2, 3, 4, 5, 6. Now, some of you might be cruising and get done early. There's nothing stopping you from keeping on, keeping on. I don't want to stop you. But overall, I am just expecting people to get that far because the concepts are that challenging. 10 and 11 at code.org are tough. Traversal used to be an APCSA, not an APCSP. So it is a much more challenging skill. And I beg you to try your hardest to wrap your head around how those things work and do those practices. Tomorrow, we're going to do data sets and we're going to build a cool weather app. It's called the Random City Weather app. It's really cool. You'll also be able to get the data for Madison, I think is our closest city in that app. And I am already working on videos so that you have some walkthrough help. People found that helpful in the last app, so I'm going to use that as well. You know, I'll do anything for views. So we'll get that done tomorrow. So feel free to get started on all that. I'm going to give you, looks like I'm giving you about 45 minutes because I want to stop you at 1:30. So for about the next 45 minutes till 1:30, can you work on those tasks? Are there any questions before people get started? Yes, there are some. Yay. Oh, it sounds good. Okay, good feedback. Thanks, everyone. I'll be watching you via GoGuardian and chatting with you there and encouraging you not to be on Google Earth, Aiden, and work really hard on this task. Good luck, everyone.